Hello and welcome to a lesson on fractions, equivalence, addition and subtraction. What we're going to aim to do in this lesson is to add and subtract simple fractions. But before we can do that, we have to understand about equivalent fractions, that is, fractions that have the same value as each other. So that's where we're going to begin, looking at the equivalence of fractions. I've got here a wall built out of different sized bricks. So let's call this top one whole number. And we can see the second row is then 2 halves, because 2 halves make a whole. The next line, I've got 4 quarters. They make a whole. How many eighths make a whole? 8. That's why we call them eighths. 16ths, how many of those would make a whole number? 16. Now what I'm going to do now is write down as many equivalent fractions as we can see. And I want you to be thinking about it at the same time. You try and identify them before I do. So to get started, let's say a half is the same as 2 quarters. We can see there that 1 half is the same as 2 quarters. Now have a look at the wall and see what else is a half the same as. Well, hopefully you've recognised that a half is the same as 4 eighths. What else is a half the same as? It's the same as 1, 2, 3, 4, 5, 6, 7, 8 sixteenths. Right, I think we've got everything from the diagram now that's the same as a half. What about a quarter? Have a look. What is a quarter the same as? It's the same as 2 eighths. Or it's the same as 1, 2, 3, 4 sixteenths as the same as a quarter. Right, let's take a few different fractions. What about 3 eighths? 1, 2, 3 eighths. What's that the same as? Well, we can say it's the same as 6 sixteenths. What about 3 quarters? What is that the same as? 3 quarters is the same as 1, 2, 3, 4, 5, 6 eighths. And it's also the same as 12 sixteenths. How about 5 eighths? 1, 2, 3, 4, 5 eighths is equal to, well, we get 2 sixteenths for every eighth. So instead of having 5 of them, we've got 10 of them. Now there's some special relationships here. You can see that I'm multiplying the top by 2, I'm multiplying the bottom by 2. I multiply the top by 4 to get from 1 to 4, and I multiply the bottom by 4 to get from 2 to 8. Here, I multiply the 3 by 2, I multiply the 8 by 2. Let's have a look at one more. 7 eighths is the same as how many sixteenths? 14. The bottom has been multiplied by 2, the top's multiplied by 2. Right, let me have the support of this diagram once more and write down what we found out about a half. A half was equal to 2 quarters, which is equal to 4 eighths, which is equal to 8 sixteenths. But what else is a half equal to? Let me borrow a diagram from later on in the lesson. Look at this diagram. This is split into halves, thirds and sixths. And we can see that 1 half is the same as 3 sixths. So let's go back and write a more comprehensive list. A half is equal to 2 quarters, but it's also equal to 3 sixths. It's equal to 4 eighths. Now before I get to 8 sixteenths, I could write it's equal to 5 what? 5 tenths. It's equal to 6 what? 6 twelfths. It's equal to 7 fourteenths. It's equal to 8 sixteenths, which we've already had. But I could say it's equal to 25 over 50. I could say it's equal to 100 over 200. So in actual fact, as long as I multiply the top and the bottom of the fraction by the same number, I don't change its value. And that's an important skill you have to be able to rewrite fractions in a different form. So I can multiply the top and bottom by any number without changing its value, but equally we can go the other way. We can do what we call cancelling. 8 sixteenths is the same as a half. So I can divide the top and bottom of a fraction by the same number without changing its value. So I can divide this one here by 8. 8 goes into 8 once. 8 goes into 16 twice. So I get 1 over 2 is a half. This one here I could divide by 25. 25 goes into 25 once. 25 goes into 50 twice. So 25 fiftieths is the same as a half. Now, we can't be sort of having a wall to support us every time we want to deal with fractions, so it's important that we can work without that. So let's have a look now at equivalent fractions. I've got 3 pairs of equivalent fractions, but there's a number missing in each case, and we've got to find that missing number. 2/3 is the same as how many ninths? Let me add a bit of colour to this diagram to show what's going on. What's happened to the 3 to get to 9? We've multiplied it by 3. But whatever we do to the bottom of a fraction, we must also do to the top if we're going to keep the fraction the same size. So we need to multiply that by 3. And 2 times 3 is 6. So 2/3 is an equivalent fraction to 6 ninths. What about this second one? How do we get from 18 to 6? Well, we've divided this time, divided by 3. So we must do the same to the top. 15 divided by 3. And 15 divided by 3 is 5. So 15 eighteenths is equal to 5 sixths. Now that's what we call cancelling. We've given the fraction in a simpler form. The smaller the numbers, the simpler we consider it to be. But it's still the same fraction, it still has the same value. Let's move down now and look at another pair. 4/5 is equal to 16 over something. Well, what have we done here? We've multiplied the 4 by 4. And whatever we do to the top, we must do the same to the bottom if we're going to keep the same value. 5 times 4 is equal to 20. So 4/5 is the same fraction as 16 twentieths. But we might, when we're adding and subtracting fractions, we might want 4/5 written in twentieths. So it's important that we can do that. Going the other way, here we have 10 to 5. We've divided by 2. So we need to divide the bottom by 2. 16 divided by 2 is 8. So 10 over 16 is the same fraction as 5 over 8. And let's look at the final pair. 3/4 is something over 28. Well, we've multiplied the 4 by 7 to get 28. 7 4s are 28. So we must multiply the top by 7. 3 times 7 is 21. So 3/4 is the same fraction as 21 28ths. And finally, 15 over 25 is equal to 3 over something. How have we got from 15 to 3? We've divided by 5. So we do the same to the bottom. Divide by 5. And 25 divided by 5 is 5. So 15 25ths is the same as 3/5. Now this would be a good time for you to pause the video and have a go at exercise A, which is exactly like the examples on this page. Right, we're now ready to tackle the main part of the lesson on adding and subtracting fractions. I have a diagram here to help me to start with. I'm looking to add a half to a third. But I can't add a half to a third directly because they're not in the same units. Halves are not the same as thirds. So I need to express each of those fractions on a common denominator. The denominator will be 6 because a half can be written as 3/6 and a third can be written as 2/6. So if I add 3 of them to 2 of them, I get 5 of them. So I know now from this diagram that the answer will be 5/6. There's a half, 3/6. A third I can see is 2 more sixths to give 5 altogether. So how do we set that out? Well, we first of all have a single line for the fraction. We're going to combine the two together. And the lowest number that 2 and 3 will go into is 6. That's why I'm using sixths. Now then, we're converting these into sixths. What have I done to the 2? I've multiplied it by 3. So to keep it the same, we times the top by 3. 1 times 3 is 3. We add in the fraction. What have I done to the 3? I've multiplied it by 2. So do the same to the top. 1 times 2 is 2. And on the top now I can see that I've got 3 add 2 is 5. And that's what gives me the answer of 5/6. Subtraction works in a very similar way. I'm still going to need a common denominator for the two fractions, a denominator that's the same for both of them. So 3 times 2 is 6, that's the lowest number they'll go into. So again, we put everything over 6. Now I want this one expressed in sixths. I've multiplied the bottom by 2, so do the same to the top. 2 times 2 is 4. This time I'm subtracting, taking away. I've multiplied the 2 by 3, so do the same to the top. 1 times 3 is 3. Now both fractions are expressed in sixths. I've got 2/3, which is 4/6, and I'm subtracting a half, which is 3/6. So there'll be 1/6 left. 4 take away 3 is 1, and the answer is 1/6. Right, I'm now going to work through 10 examples, 5 addition and 5 subtraction. And I'll be finding common denominators, but I won't be using diagrams to help me. Right, number 1, a quarter plus 2/5. So the first thing I've got to do is find a common denominator. What's the lowest number that 4 and 5 will go into? If you can't spot anything else, multiply them together. They'll both go into that. 4 times 5 is 20. And there isn't a number less than that both 4 and 5 will go into. Now, what have I multiplied the 4 by to get 20? I've multiplied it by 5. Do the same to the top. 1 times 5 is 5. Plus, because we add in the fractions. What have I multiplied the 5 by to get 20? I've multiplied by 4. So times the top by 4. 2 4s are 8. And now we can work out what's on the top. 5 add 8 is 13. So the answer is 13/20. Move on to example 2. 2/3 plus 1/5. First thing to do, find a common denominator. What's the lowest number 3 and 5 go into? 3 times 5 is 15. We can use that. There's nothing smaller than that. I've multiplied the 3 by 5 to get 15, so do the same to the top of the fraction, the numerator. 2 5s is 10. Plus, I've multiplied the 5 by 3 to get 15, so multiply the 1 by 3. 1 times 3 is 3. And now on the top of the fraction, 10 plus 3 is 13. So the answer is 13/15. Example number 3. 3/4 plus a 1/6. Now then, what's the lowest number 4 and 6 go into? They actually go into 12. If you multiply them as we've been doing up till now, you'd have got 24. But it doesn't really matter, as you'll see. I'll do it both ways to show you. But if we've noticed that both those numbers go into 12, what have I multiplied the 4 by to get 12? I've multiplied by 3. Let's do the same to the top. 3 3s are 9. Plus, what have I multiplied the 6 by to get 12? I've multiplied it by 2. Do the same to the top. 1's 2 is 2. So the answer, 9 add 2 is 11. So the answer is 11/12. Now then, let's have a look and see if I hadn't noticed that 4 and 6 go into 12. If I'd multiplied them the way we've been doing up till now, 4 6s are 24, so I'd have got my denominator as 24. What have I multiplied the 4 by to get 24? Answer, 6. So multiply the top by 6. 3 times 6 is 18. Plus, what have I multiplied the 6 by to get 24? I've multiplied by 4. Do the same to the top. 1's 4 is 4. So that gives me 18 add 4 is 22, so I get 22/24. But if I look at this fraction, I can see I can give it in a simpler form. I can cancel by 2. 2 goes into 22 11 times, and 2 goes into 24 12 times. So I end up with the exact same answer. If I leave it like that, I may be penalised in an exam for not giving it in its simplest form, but it's still the correct value. Right, example 4. 4/5 plus a half. Common denominator for 5 and 2, the lowest thing they'll go into is 5 2s are 10. What do I multiply the 5 by to get 10? I multiply it by 2, so do the same to the top. 4 times 2 is 8. Plus, what have I multiplied the 2 by? I've multiplied by 5. Same to the top, 1's 5 is 5. 8 add 5 is 13, so that gives me 13/10. Now that's what we call an improper fraction, a fraction where the numerator, the top, is bigger than the denominator, the bottom. So what we can do now is we can take out a whole number. How many tenths make a whole number? 10 of them. So if I take 10 tenths out to make a whole number, there'll still be another 3 tenths left over. So the answer is 1 whole number and 3 tenths, or 1 3 tenths. Last example for our addition questions. 5/7 plus 2/3. Common denominator, lowest thing 7 and 3 go into is 7 times 3 is 21. I've multiplied the 7 by 3, so times the top by 3. 5 3s are 15. Plus, I've multiplied the 3 by 7, so times the top by 7. 2 times 7 is 14. 15 add 14 is 29. So I've got 29/21. And again, that's an improper fraction. So I can take out a whole number. How many 21sts make a whole number? 21 of them. So how many will be left? Well, if I use up 21, I'll still have another 8 taking me up to 29. So it's 1 8 21sts for the answer. We'll move on now to subtraction. Okay, 5 subtraction questions to conclude the lesson. And these are very similar to addition. We're still dealing with common denominators. The only difference is how we calculate the numerator on the top line. Instead of adding two numbers together, we're subtracting one number from another. So, common denominator for 4 and 5. The lowest number 4 and 5 will go into is 20. I've multiplied 4 by 5 to get 20, so do the same at the top. 3 5s are 15. And it's a minus sign on the top because we've taken one fraction from another. I've multiplied the 5 by 4 to get 20, so 2 times 4 is 8. So on the top I've got 15 minus 8, which is 7, to give an answer of 7/20. Example 2, 2/3 minus 1/4. Lowest common denominator for 3 and 4, the lowest number they'll go into is 12, 3 times 4. I've multiplied the 3 by 4, so do the same at the top. Always remember why we're doing this. It's because 2/3 is the same fraction as 8/12. That's what you were doing in exercise A, expressing one fraction in a different form. The second one, I've multiplied the bottom by 3, do the same to the top. 1/3 is 3. 1/4 is 3/12. And now 8 minus 3 on the top is 5, so the answer is 5/12, 5/12. Two-fifths minus 1/6. Right, what's the lowest number 5 and 6 will go into? 6 times 5 is 30, and there's nothing lower than that. I've multiplied the 5 by 6, same to the top, 2 6s are 12. Minus, I've multiplied the 6 by 5 to get 30, so times the 1 by 5, 1's 5 is 5. 12 take away 5 is 7, answer 7/30. Quickening up now. Number 4. Lowest common denominator for 7 and 2, 7 2's are 14. I've multiplied the 7 by 2 to get 14, do the same at the top, 4 2's are 8. Minus, I've multiplied the 2 by 7 to get 14, 1 7 is 7. So on the top I've got 8 take away 7, which is 1, so the answer is just 1/14, 1/14. And the last one, lowest common denominator. Well, again, this is one that you might miss. If you jump in and do what we're doing most of the time, multiplying 8 by 4, we'll end up with 32 as a common denominator. But in actual fact, 8 and 4 will go into 8. We don't need to go any bigger than 8. What have I multiplied 8 by to get 8? I've just multiplied it by 1. So I do the same to the top. 5 1's are 5. So I'm not changing it. It's just measured in eighths. Minus, what have I done to the 4? I've multiplied it by 2. Same to the top. 1's 2 is 2. So 5 take away 2 is 3. And the answer is 3/8. Now I think that's one that I should do both ways. Let's have a look. If we didn't spot it, if we said 8 times 4 is 32, we'd have had a common denominator of 32. And I'd have said, what do I multiply 8 by to get 32? I multiply it by 4. So do the same to the top. 5 4's are 20. Minus, what did I multiply the 4 by to get 32? I multiplied by 8. Do the same to the top. 1's 8 is 8. 20 take away 8 is 12, so I end up with 12/32. But we should always be looking at our answer fractions to see if they'll cancel. What goes into both 12 and 32? I can cancel by 4. 4 goes into 12 3 times, and 4 goes into 32 8 times. So providing I cancel my final answer down, I can end up with the exact same answer that I'd have got if I'd chosen the smallest common denominator. Right, that concludes this lesson on fractions. We've looked at equivalent fractions, and exercise A was based on that. And we've looked at addition and subtraction of fractions, and exercise B will give you practice at those techniques.